So let's get started today. We are going to be finishing up on the SQL queries with retrieving, and we're going to be talking about multi-table queries today involving an operation called a join. And then we're also going to consider operations for updating the database, so insertions, deletions, and modifying attribute values. And if we have time, we'll go into subqueries. I'm not sure if we'll have time or not, so we'll see. Wanted to let you know that the office hours for the TAs have now been established. So Elvis has his office hours Tuesday, Thursday from 11 to 12:30. Jaja has her office hours from Tuesday, Thursday, 2:30 to 5, so after this class. Jaja's in Mingao 338. Elvis will be in 313, but per his post this morning, he will be in the programming clinic until further notice, and he will be at a conference on Thursday, so he will not be holding office hours Thursday. Now, if you remember, the primary people to see about questions on the homework are me and Jaja, so even though you can see that my office hours overlap with Elvis's on Tuesday, I would be more your point person for answering questions about the homework as would Jaja. Elvis is going to be more your point person for trying to get points back on the homework or asking about grading questions. So kind of a division of labor there. So there's really not a big conflict between Elvis's office hours and my office hours unless you have both a grading question and a question about the homework. But in that case, you can get to Elvis's office half an hour before mine start. Okay. And then on the quizzes, please, first of all, remember you should be taking them after each class. So that's one reminder. Two, on the multiple answer ones in Canvas, I did post on Piazza the grading where if they give you partial credit for each correct answer, but they also deduct a comparable number of points for each incorrect answer. They claim that is to your advantage. I'm not sure I agree with that. However, I can't change how they grade it. That is set in stone. So remember, when you do answer, be pretty confident. You need to be reasonably confident your answer is correct. Don't guess. Because if you guess, you could end up hurting yourself just as much as helping. So be reasonably certain about your answers. And then finally, just a reminder with the homework assignments. So the first one is due this coming Saturday at 6 a.m. It's really due Friday evening. So don't get trapped into thinking, oh, I can wait and do it sometime Saturday afternoon. If you do that, it will be late and a 10-point deduction. Also remember, if it's in by Friday at 6 a.m. or earlier, you'll get a bonus 5 points. So do try to get these in early if you can. And finally, the last important announcement, Elvis did post either yesterday or today. He wants the homework 1 submitted as a set of separate .SQL files. So if you submitted them as a single .SQL file, I apologize, but please go back and change it for him so that it's a series of .SQL files. I suspect he's planning to set it up as a script. So please, in the future, also when you submit each answer to a .SQL question as a separate .SQL file. So I think that takes care of all the announcements. Yes. Okay. So, if you remember last time we discussed single relation queries on using SQL, and we had the select and project operations. So select is filtering the rows using a where clause, And project is filtering the columns by specifying the set of columns you want to see displayed. So we talked about the relational and Boolean operators you could use with where clauses. We also talked about aggregate operations, min, max, average, sum, and count, and how you apply those using which kind of command, how do you kind of use aggregate operations if you want to aggregate like subtotals for a branch. You say select from some group by. Very good. And then you can use the having clause to filter rows from the groups based on an aggregate operation. For example, you might want to only list branches with a staff count of greater than 20. So you could put an aggregate operation in a having clause. Remember, you cannot put an aggregate operation into a where clause, though. So that's a quick review of what we covered on Thursday. Today, we're going to head into multi-table queries, and they involve the third fundamental operation, which is a join. The first two fundamental operations were select and project. The third fundamental operation is join. And the rationale for joins is that often the information we need is in multiple tables, and therefore we have to combine the information from multiple tables to get the answer to our query. And here I have two relations, a branch relation and a staff relation. And I might have the query, what address does Brad Vanderzanden work at? So this query right here, what address does Brad Vanderzanden work at? Well, if you look at the staff, you can see first name and last name, but there's no address such as street, city, or postcode here. There is, however, the branch number at which Brad Vanderzanden works. And you can use that, it's called a foreign key, to look up this address information in the branch relation. So if I, for example, work at branch 003, I would find branch 003 in the branch relation, and then I could pick up the street, city, and postcode. Now, in order to do that, I perform what's called a join operator. And in my from clause, I will now list multiple relations, and I may alias them. Let me see if I got the query. So actually, I don't actually have the query. So let me write the query here. Make sure I don't have the query. Yep, okay. Or maybe I do. Nope, I don't. Okay, so here would be the query. I would select, let's do it in another color. Let's do it in bright blue. I said bright blue. It still wants red. Let's select it and say we want it in blue. There we go. Okay, so we'd say select, and I want I'll explain the B in a moment, street, B.city, B.postcode. Ignore the fact that PowerPoint is capitalizing the B's. From branch, and now I can use an alias. That B is called an alias. So it just allows me to more succinctly refer to the branch relation in the where clause. I could write out the relation each time, but this allows me to refer to it more succinctly. And I'm going to call staff F where last name equals Vanderzanden and first name equals Brad, and this is the important one, S dot branch number equals B dot branch number. So this last equality is what we call the join. So right here, this is the join. It is taking the branch number that it locates in staff using this part of the where clause. Then it finds whatever branch number is associated with Brad van der Zanden, and then it uses this equality to retrieve the corresponding tuple from the branch relation. And you can see up here, we are retrieving the street, city, and postcode from the branch relation. So we qualify the attribute names with the relation. Now, if there's no ambiguity, you can omit the relation name. So I really could have said select street, comma, cities, comma, postcode there because there's no ambiguity. Okay, the only place that those attributes are actually, so I could have written it like this because there's no ambiguity as to where those attributes come from. But it's kind of nice from a documentation standpoint to do it. Someone looking at it will know which relation they're coming from. And then down here, it's absolutely required because the branch number is common to both the staff and branch relation, and therefore it would be ambiguous if I left it unqualified. Now, if I left off the B and the S, that would be fine. If I did that, though, then I would have to write out the staff relation here and the branch relation here. So you can do it either way. You'll also notice that I did not put any qualifier in front of L name and first name because, again, it's unambiguous. But you should be consistent. For consistency's sake, I really should have said B dot L name and B dot F name here so it was clear to someone reading the query where the attributes are coming from. Okay, so that's the join operation in its simplest form, a two-table join on a common attribute. And as I said, joins make use of primary keys and foreign keys. So the foreign key links into the primary key of another relation and is what we use to retrieve the appropriate information. Okay, so here's another one. I'll kind of I've already shown it to you so you can look it up. So let's do another one from student courses. So let's say down here we have student and we have student courses. And let's say that we want to find all the courses that anyone with the last name of Mouse is taking and their score and grade and the course ID. So to get that, we would say select, and now we want from the student, we want the first name and the last name. And from the student courses, which I'll abbreviate SC, we want the grade, the score, and the course ID. And we'll be selecting from student, which I alias with an S, and from student courses, which I alias with SC. And then I want everything that has a last name of Mouse. So it doesn't matter what the first name is. And now the join condition is going to be on the student ID. So it's going to be s.id equals sc.student.id. So in this case, student ID is a foreign key that is looking up or being used to find two, well, it's the opposite in this case. In this case, we're using the student ID that we find with mouse to locate the appropriate records for that student in student courses. But in fact, student ID is the primary key in student ID is the foreign key in student courses. And when we do it, we get results for Minnie Mouse, Mickey Mouse, and Jerry Mouse. So all the mouses. Okay? And if we wanted this ordered by last name and first name, how would we do it? So what could I add to this to get it ordered by last name first and then by first name? Order by. And in this case, because I know that I'm only selecting mouse, I could simply say first name. Because every last name is a mouse. It'd be kind of useless to say order by last name first because everything is a mouse. Okay. So questions about just simple joins. Okay. So SQL has some syntactic sugar that it uses so that you don't always have to write out that equals, and also so that you can make it clear that you are doing a join. So I could have said here, select all of this, and instead of, when I said from, I could have said from, whoops, could have used the keywords inner join. And then over here, instead of saying where, I would have said on. So that makes it clear to the reader that I'm doing an inner join. And we'll get to what an inner join is in a moment. Don't worry about it for the time being. Just that is syntactic sugar is also, instead of, it makes it clear to someone reading the query that it's a join. And then let's say, now in this case, the join attributes had different names. So it was ID in student, and it was student ID in student courses. But let's say that the attribute was the same. Okay, so for example, in that branch query back here, the branch number was the same. So then I could actually simply say where, I could say select from branch equijoin. Make sure I get this right. Actually, I can just say natural join. Oh, let's start with inner join first. Using. So I could have said inner join and started off with a using clause, using branch number, because it's the common thing, and then where. And again, that's just syntactic sugar. Makes it a little easier to read. So I'm doing joining branch with staff using branch number, and then it just assumes it's equality. So a little more concise. But wait, I can get even more concise. So as long as I want to do the join on all common attributes, which I typically want to do is do a join on all common attributes, I could simply say natural join, and then I could get rid of even this using clause. And now it would do a equality match on all common attributes. In this case, there's only one common attribute, which is branch number. But if there was a second one, let's say that I also had, for some odd reason, I had postcode in here for staff, it would actually do the join on both the postcode and branch number attributes. It would be like saying where b.branch number equals s.branch number and b.postcode equals s.postcode. Okay, so inner join allows you to specify a subset of the attributes on which to do equality. Natural join says we'll use all of the similar or identically named attributes in our join. So feel free to use any of these forms in your homework assignments, on exams, but make sure you're familiar and can recognize all these forms. If I give you a query in any of these forms, you should be able to interpret it for me and give me an English language description of what's going on. Okay, and again, this is just syntactic sugar. It's not changing the query in any way. Okay, so again, you can say inner join using, or you can say natural join, in which case it uses all the common attributes. And you can always put where clauses after that to filter rows. Okay, well, that was a very simple one, but oftentimes we have to join more than two tables. The information may be spread across more than two tables. So here's one from Dream Homes where we want to list the staff who manage properties, and we want to do that for each branch. And we want to include the city in which the branch is located and the properties they manage. And it turns out that this information is spread across three relations: the branch, the staff, and the property for rent. The property for rent relation lists the properties that each staff manages. So in order to answer this query, we're going to have to gather up information from three different relations. Okay, so we are getting the branch number, the city, the staff, the person's staff number, their first and last name, and the property number that we're managing. And you'll see that the where clause, I wrote out the joins explicitly. So I said where b.branch number is equal to s.branch number and s.staff number is equal to p.staff number. So what this is doing is every time that we match a branch number, then we'll also get that person's staff number and match it to a staff number in the property, and that will at the end give us the answer to our query. Okay, so we're going across three different relations to get this information. Now, to give you another example, let's go back to our mini mouse or our mouse query. And you'll see that when we did the query, it gave us first name, last name, grade score, and the course ID. But let's say we wanted to also know the name of the course, like Introduction to Computer Programming or Introduction to Accounting. Well, that information is not in student courses. If we look at student courses, it has the course ID, but it doesn't have the course name. If we look at the courses relation, we see that there is a course name. So what we're going to have to do is use this course ID right here to look up the course name in the courses relation. So I'm going to add an additional join . Whoops. Okay, so we're going to do an inner join of s dot ID equals sc dot course ID. And then we're going to do a natural join with courses where, so all I did here was add this clause, natural join courses, so that I could pick up the course ID, and I'm going to add a alias here for courses. And then at the beginning, in addition to all that information, instead of course ID, I'm going to print out the course name. And it didn't like that.
The SID was SC course ID. The SID is the student ID, right?
Yes. That should have worked. Oh wait, I'm doing it twice. I don't need it there. Yeah, I'm still not getting it. Select.
I think S the ID is the student ID, not the course ID.
Oh, I see what you're saying. You're right, you're right. I see where I'm going wrong. Thank you. Right here, I need to be matching with student ID. There we go. Okay, so right here, it will. Come on. Don't want the dictionary. No, I don't want the dictionary. No Apple, no dictionary. Well, it's not really. Okay, so that was the on. And so the first join joined the student ID with the student courses student ID, and then I had a relation form from that that included course ID, and I did a natural join with courses, which also had course ID, and that gave me my answer. So that was a 3-table join. And you can get 4-table joins, 5-table joins. They can get arbitrarily complicated, but hopefully you get the point. The point is use a join to link information from different tables, and you use these so-called foreign keys as your links. They're kind of like pointers that allow you to put tables together, glue them together. So it's these foreign keys that allow you to do it. And in student courses, we can go back here to student courses. There's two, both student ID and course ID are foreign keys. The student ID is a foreign key into the student relation. The course ID is a foreign key into the courses relation. So each of those two keys allows us to form a join with another table. Okay? So that's the basic idea. And you're typically doing equality when you match the foreign key with the primary key. Okay? So we can get a little more complicated. So we can do a join and then do a group by on the results. So in this case, we want to find the number of properties handled by each staff member. We may want to do that to enforce a constraint that no staff member manages, say, more than 100 properties. So in this case, we need to group properties by staff member. But in order to do that, we need to join the staff and the property relations, because the staff relation has all the information about staff members. The property relation or property for rent relation has all the information about the properties for rent. So we select the first name, last name, the branch number of the staff member, their staff number, and the count as, and notice here we're aliasing count star to staff count to get a nice one. And we are joining on the staff numbers of the two relations. So that's our join. And then we want to group by the branch number, and within that by the staff number. So it's possible a staff member works at 2 different branches. So we don't just group on the staff number, although honestly the way the book, this is an example from the book, and the way the book said it, you actually probably should just be grouping by staff number, because this one's really giving us a report that might say at branch B3, Brad manages 5 properties, and at branch B8, Brad manages 15. But be that as it may, it's first ordering it by branch number and then by, or grouping by branch number and then by staff number. So that will give us a count of the total number of records in each group. So this count star counts the total number of records in each group. Now, there's also something a little fishy about the select clause and the set of attributes in it. Seems to violate something that I said last time about aggregate operations and what attributes could appear in a select clause. Okay? So if you can maybe cast your minds back to last Thursday, there are 2 attributes in this select clause that looks like they should be illegal. Can someone tell me what those 2 attributes are and why they should be illegal? Very good. So it's F name and L name. Can you tell me why? Very good, because it's not in the group by clause. So you're only supposed to be able to include in the select clause either attributes that are in the group by clause or that are in an aggregate operation. And that's not true of first name and last name. Well, it turns out that what it is able to do is create the query optimizer can create what's called an intermediate relation. And it will create an intermediate relation that essentially does the join of the staff and the property for rent and gets the counts. And then the smart query optimizer will take that intermediate relation and rejoin it with staff. So while you're not seeing it, effectively what's going on is it's going to do a select something, something, something from staff S, natural join, and it's going to do a select, and this is what's called a subquery, so don't worry too much about it right now. So in effect, what it's doing is it's taking this query, it's putting it right there, and it is creating what's called an intermediate relation. And when it's done, it then is natural joining it back with the staff relation again to pick up these 2. So that's what's happening under the covers, and the book doesn't explain that nuance. Took me a little while to figure it out. Luke.
So how does the count star kind of work? Because that seems like a little
Ambiguous? Yes. So Luke's question is, how does the count star work? The way the count star works is that it is applied to each group that is whoops, this pen doesn't work. So each group that is formed by this group by clause. So the group by clause basically takes the rows of a relation and groups them together. So for each group that's distinct, the count star is applied to that group. Does that make sense?
Yeah.
So you're right, it looks ambiguous, but that's what's happening. It's being applied individually to each distinct group as defined by these 2 attributes right here. So it's like these 2 attributes are the primary keys for the group.
So it is happening in that subquery.
Yes, it is happening in that subquery. So this is the book glossing over a detail that because it had not gotten to something yet. I just wanted to alert you to the fact that technically this query is illegal and that the query optimizer is doing something clever to make it legal. It's actually transforming this illegal query into a legal query. Okay. Questions thus far? Yes. Pardon? I'm not 100% sure because actually I'd never loaded in the Dream Home relations and checked this query to see whether it worked or not. So if you do your queries at home on your own SQL database, please check that those queries work on our Hydra system. Okay, the reason is that if you'll note when we log in on Hydra, it says actually welcome to the MariaDB monitor. So we're actually not using a MySQL release. We're using a MariaDB that is in effect looking like MySQL, but there could be differences. So that's why I'm saying if you're running your own MySQL server at home and the query works there, please make sure it also works on the Hydra system because it's a slightly different thing. Just like MySQL is supposed to behave like real SQL, but doesn't always do so. Okay. Let's get rid of that ink. Other questions? Okay, so moving on. So just so you know how the join gets computed, because many of you are CS majors and should at least understand what's going on behind the scenes. The general algorithm, although query optimizers aren't this stupid, is as follows. You first form the Cartesian product of the tables that are named in the from clause. And this is the query optimizer is not so stupid as to do this. Because that if you have, say, just think about for a moment, if you have real world systems, something like 1,000 tuples in one, and say 30 in another, and maybe 300 in another, the number of tuples in the Cartesian product is whatever that product is, which is in the millions. That's hugely inefficient. So that's not how it's actually done. It's just theoretically how it gets done. In practice, you would first do two, which is you would first apply the where clause to get maybe the first relation down to 10, the second relation maybe down to 5, and the third relation maybe down to 15. That's far fewer tuples. So in practice, you would probably apply step 2 first to filter out the rows from each relation. But theoretically speaking, you first do the Cartesian product, get a huge relation, apply the where clause to that huge relation. Then, so that's the select. So step 1 is like the join, select 2 is like the select, step 3 is the project. You eliminate columns that are not in the select list. So this is kind of like the join. This is kind of like the select statement. This is kind of like the project. So 3, 2, 1. So select filtering out rows, project filtering out columns. Get rid of that. Okay, sometimes you have to use distinct to eliminate duplicate rows from the result table. So if distinct has been specified, you would use that to eliminate duplicate rows from the result table. Okay, so if we go back here and darn it. So I am going to get from the student court, what do I want to do? Well, just as an example, I will say select star from student courses SC courses C, where SC dot course ID equals C dot course ID. And that gives us a huge result with a lot of duplicates because we're going to end up with, let's see, one is CS 140 Introduction to Data. Actually, there may be no duplicates there. What's the duplicate I want? Let me go back in my notes because I had it earlier, I think. There we go. Okay, so let's say that what I want is just the course name and the course ID from that join. Okay, if I don't use distinct, I use distinct, but if I don't use distinct, I get 30 results. And it turns out that if I order it by C.course ID, you'll see there's duplicate. Fundamental algorithms is showing up 4 times, CS for non-majors once, intro to data structures 4 times. So sometimes I have to apply distinct to a query. So that's what's happening here, is that sometimes I need to apply distinct, then it applies group by and order by last. So that's theoretically what's going on. As I said, a real query optimizer doesn't do it in this order, but theoretically that's the order, because theoretically we don't care about optimizing. Okay, next. There are 2 types of joins. You already saw me use the term inner join. So an inner join says that we include a row in the result only if it matches a row in another table. That is, its foreign key matches the primary key in a tuple in the other relation. Well, sometimes we actually want a row to appear even if it matches no row in another relation. And if we want that, we call it an outer join. So an outer join will retain rows that do not satisfy the join condition, meaning they will retain rows that don't have a matching tuple in another table. Okay, and then we can talk about a left outer join, a right outer join, and a fold join. And it's very intuitive. Left join means we retain rows from the left relation that don't match rows in the right relation. Right outer join means that we retain rows in the right relation that don't match rows in the left relation. And a full outer join means we keep rows from both the left and the right relations that don't match. The best way to see this is with an example. So we might want to list the branches and properties that are in the same city along with any unmatched branches. So if a branch is not in a city with any property for rent, maybe we want to shut it down. So we might want to actually see branches that don't match any property. And so in this case, we say select branch 1B left join with property for rent 1 on b.pcity equals p.pcity. And you see that these are my two simple relations. And which branch doesn't have a matching city? Bristol. Very good. So when we get the result, you'll see that Bristol shows up with nulls in the property number and p-city attributes, because if a row doesn't match any row in the other relation, we use null values for the attributes in the other relation. So this makes it clear that Bristol didn't match any city in property for rent. Okay, we could do a right outer join, in which case we want to know about properties that don't match any city. Maybe we're expanding. We've got a suburb of London where we're all of a sudden managing a lot of properties, and maybe it's worth putting a branch out there. So now we do a right join, and we will include in the result any properties that don't match a branch city. So in this case, we look back at our original relation. Which property doesn't have a matching branch, so to speak? Aberdeen. So when we look at the result, we see that Aberdeen is in the relation, but has null values for the branch number and branch city. And then we can do a full outer join with the syntax full join. So remember earlier you saw inner join. But other types of joins are left, right, and full. Those are all outer joins. And now Aberdeen shows up with nulls and Bristol shows up with nulls. So we're getting rows from both relations that don't match. Okay, so review. 5 types of joins. Inner join, natural join. Natural join is simply an inner join that matches on all common attributes. Left, right, and full joins. All 3 of those joins are outer joins. Inner and natural are inner joins. Yes?
Natural join requires that they have the same names.
Natural join requires that there be at least one common attribute in the 2 relations. If there isn't, it actually takes a Cartesian product, which is a disaster. It will work. It'll take a Cartesian product. That's not what you want. Okay. Other questions? Yes?
When you're doing inner join using the notation, what do you do to specify 2 attributes that have different names for those names?
You can't. Then you have to say inner join on, and you have to use the equality. So if they have 2 different names, you can't. The using clause can only be used when it's a common attribute. Okay, you almost never do it because you almost always want to do a natural join. The only time you'd use using is when you wanted to basically use a subset of the common attributes, which is incredibly rare. You're welcome. So again, to reiterate, the question was, what happens if I want to use the using clause, but the attribute names are different? You can't. You have to say join on and use an equality statement. Other questions? Okay, so that's the end of join. Whoops, not the end of joins.
How common is it for you to have 2 relations which share more than one attribute?
Actually more common than you think. It's going to happen when you don't have an artificial. So the question, first of all, is what happens, how frequent do you have a join where there's more than one common attribute? And the answer is it occurs when you're not using artificial keys. When you're using artificial keys, it won't happen because there'll be one common one. But If you're not using artificial keys, like in the booking relation for the hotel schema, you're going to end up sometimes with multiple ones. Okay, so that's when you would get them. So I would say probably in the real world, not frequent, because you usually in the real world invent artificial keys. Okay, even the booking relation, in the real world, you get a confirmation number on your booking. That's the artificial key. So I'll say rare. Other questions? Okay. However, in this course, more common, because I want to drive home the points of multi-attribute, natural joins, and the like. Okay. So there's a few other ways you can combine tables other than joins using set operations, and they are set union, set intersection, and set difference, which behave exactly like you would imagine. So set union returns all the rows in A or B. Set intersection returns all the common rows from A and B. And set difference returns all the rows in A that are not in B. So again, it's easiest to give you an example. So let's say a university has 4 types of relations: staff, professors, students, and administrators. Okay, let's say we want to get all employees. Then what we want is a union on staff, professors, and administrators. Let's say we want to know about professors who are also administrators. That's an intersection of the professors and the administrators set. And we want to know all administrators who are not professors. That's set difference. So that's using except. Now, only, I think set union is supported by MySQL, but intersection and set difference aren't. When we get to relational calculus next week, you will find out how you can implement set intersection and set difference in MySQL. These are operations in full-blooded SQL. So except is set difference, intersection, and union is the union operation. Now, you may wonder why I don't say staff, union, professors, union, administrators. The reason I don't do that is because in order to do any of these 3 set operations, they must have an identical set of columns. And probably staff, professors, and administrators probably don't have a common set of columns. So what I'm doing is this select is creating projected relations that contain only the name attribute. And now all 3 relations, the subrelations, all have the same column, which is name. So we say that in order to do these set operations, they must be union compatible. We don't say intersect compatible or set difference compatible. We simply say union compatible for all 3 operations. It means that it's the same number of columns, each pair of columns drawn from the same domain, and actually they're supposed to have the same name for the columns as well. Okay, so same name and domain. That's why we had selects. Okay, again, I believe only union is implemented in MySQL. But you can do intersect and set difference from the operations we've already seen. I'm just putting it off for the time being, because I want to move on to modification statements, which fortunately are quite easy. We have about 20 minutes to cover them, and that's all we'll need. We may not even need that. So the 3 types of modification operations, probably should have put them here, are insert, update and delete. So we'd like to insert tuples into the relation. We'd like to update attributes, and we'd like to delete tuples. So that's the form of the insert. Let's just head straight to examples. You can read the slides later. Okay, I just find it so much easier to look at an example. So insert into staff. So insert into the keyword. Staff is the relation name. Values, and then in parentheses, a comma-separated list of the values. If you do it like this, you need to provide a value for each attribute. If you come up short, you may get an error message from the query optimizer saying you don't have enough values. And of course, it's going to be a one-to-one matching of columns. So whatever is the column name for column 1 will get SG16. So it should go without saying that you need to make sure that you provide the values in the same order that the columns are. Yes. The question was, can you include null? Yes. So I could have put null for one of these values as long as null is permitted for that column. Okay. Sometimes, like for a primary key, null is prohibited. But if null is a permitted value, then you just NULL, all caps, is the literal. No quotes. Okay? And in this case, what I'm doing is I am using a subset of the columns, but I'm giving first the list of the column names for which I'm providing values. So in this case, I'm providing values for 6 of the columns. The remaining columns will receive either null or they will receive the default value for that column. You can also, when you set up a relation, specify a default value for a column. We will get into that on Thursday when we talk about data definition language, how you can specify initial values for a column. So if you do an insert and you omit a column name, then it will either get the default value for that column or null if null is a permissible value, or an error message if it's a required column and you have not provided a value or a default value. Okay, so this actually nicely summarizes the 2 different forms of insert. You may omit a column list, in which case you have to provide values for every column, or you may provide a column list, in which case you only have to provide values for those sets of columns. Simple. Okay, so I know that this might look intimidating, this little insert statement, but really this example shows what it's all about. So pretty simple. Yes. And you, oh, go ahead.
Is there a way to insert multiple values at once? What's the delimiter for a new set of values?
I think it's a comma. Not having done that before, I wouldn't be positive, but I suspect I could have simply said here, actually, let's give it a try. Insert into student courses, values, let's see, I think it's, student ID, course ID, grade, and score. Student ID 003, course ID AC 102. Grade, we'll give them an A with a score of 95. And now we'll try this and see if it works. 003. We'll try CS 100. Grade of B and a score of 87. See how that works. It worked. So query OK, 2 rows affected, records 2, duplicates 0, warning 0. So it's just a comma separated list. You want to do multiple ones. Okay, and that's what's happening in those scripts that I give you for the homework assignment. So for example, I have no idea what's going on upstairs. So you can see I just gave you a whole bunch of inserts after I created the hotel. You're supposed to add some more just to flesh it out for homework 1. Okay, so insert is easy. The others are easy too. Update. So update allows us to update a table, setting columns, one or more columns, you separate them with commas to data values where some search condition. So here, you're almost always going to have a search condition because you want to update certain rows. If you forget the where condition and, oh my gosh, I have done so, you update every column, which is a disaster, leading you to hope you have a backup. So you don't use where with insert because it's unconditional, but you do use update it with update. So here's an example using some arithmetic. I'm giving all staff a 3% pay increase. So that's actually one where I don't use a where because I want every salary field multiplied by 1.03. Just make sure you don't multiply by 0.03 or you're going to have a lot of unhappy employees rather than a lot of happy employees. Okay, here we just want to give the managers a 5% increase. We don't want to give everyone, so we update the staff, set the salary to be the salary times 1.05, where the position equals manager. By the way, if you cut and paste these queries from my PDF into an SQL query optimizer, you will get error messages because the PDF doesn't use the quote symbol for these two. These ASCII codes for this and this are not a quote, so you'll get error messages. So if you try to cut and paste, actually paste maybe into a text editor, change these quotes to real quotes before you do anything. Because that's why the PDFs won't paste and work precisely otherwise. You don't have to use arithmetic here. I could say set salary equal to 50,000. Doesn't have to. I can set it to a specific value. Okay, here's an example of modifying multiple attributes in one statement. So I'm setting the position to manager and the salary to 18,000 with a comma between the two attributes I'm setting. Notice only one set statement. Okay, so update, also pretty simple. Questions about update? Yes?
Can you use it to make new columns?
Pardon?
Can you use update to make new columns?
No. Good question. The question was, can you use update to create new columns? And the answer is no. You have to move to the data definition language to create new columns. So this only, insert, update, delete, only allow you to modify an existing framework or values in the database. If you want to modify the structure, which is what adding or deleting a column is, you have to go to the data definition language. Okay, finally, delete, and again, I'll make the same caveat. You can only use delete to delete tuples. You can't use it to delete attributes. To do that, you'd have to move to the data definition language. So delete from table, and again, you might want to wipe out the entire table, but probably not, because if you say delete from table without a where condition, it will delete all the tuples from the table, but leave the table still there. There is an easier way to delete everything in the table, which is to say drop the table, D-R-O-P. That will actually delete everything in the relation and it will delete the table as well, which is probably what you want to do. And that's a DDL command, though. So at any rate, delete will only delete tuples. You can give it a search condition. Again, normally you do give it a search condition. So here's an example. We're going to delete all viewings relating to property G4. So delete from viewing where property number equals PG4. Probably would never do the delete statement at the bottom just because of how useless it probably is, but you never know. So delete's also easy. Just delete from, name of relation, where, and then the filter. And you don't use joins on any of these. All of these three, insert, delete, update, are always done on a single relation. You don't use joins on them. You don't use aggregate operations. So they're really simple. Okay, questions? Okay, I am going to just introduce subqueries without going into them in great detail because I know they're not part of today's lecture, but I've shown them to you a couple times. And actually, if you want, you could solve a homework problem or two using them. So I will show them to you, a quick introduction. Don't worry, I will go over them again on Thursday. Okay, so a subquery is one where you have nested select statements. I showed you one earlier to show how you got those supposedly illegal attributes into a select. So here we want to list staff who work in the branch at 163 Main Street. So we could say select these staff attributes from staff where the branch number is equal to the branch number at 163 Main Street. So where branch number equals, and then the select, this nested select right here, evaluates to a scalar value. So you evaluate the nested selects from the inside out, from the most deeply nested one out. So this select statement would be evaluated first. It might evaluate to B003. So then the query optimizer would substitute B003 in there, and you would end up selecting staff this way. Now, most of the time, subqueries can be accomplished with joins. So why are subqueries even in SQL? Two reasons. One, occasionally we need them to perform an operation that cannot be done with a join. I'll show you that in a moment. Two, most end users seem uncomfortable with joins. Some of you also won't be particularly comfortable with joins. And it just seems that end users often prefer to use subqueries in preference to joins. Okay, I could have solved this query with a join. In fact, I think I have it here. That's the equivalent query with a join. I simply select from staff branch where the staff.branch number equal branch.branch number, and the street is 163 Main Street. So it's the same thing. Okay, usually they're interchangeable. Yes?
What's the overhead difference using a join versus using
So the question is, what's the overhead difference between using a join and a subquery? A good query optimizer will make them identical. Okay, so a lot of research into finding out the equivalences. Okay, so query optimize. So that's why, as a user, you really don't generally need to care about the form of the query, because a good query optimizer can pretty much take any form and reduce it to a common form. So don't worry about how you write it. Write it in a way that's most natural unless I specify how I want it done. On a test, I might say use a subquery, or on a test, I might say you have to use a join. But otherwise, for the homework, write it the way that you're comfortable with. Okay, so this is the last slide for today. There's three types of subqueries. We will get into the types next time. The simplest type is the scalar subquery. It's the one most commonly used. And here's an example that could not be easily accomplished with a join. And what we want is to find all staff whose salary is greater than the average salary. And we want to know by how much their salary exceeds the average. And we can't actually say, remember, we can't say something like, we might like to say, where, come on, why is this happening? We might like to say salary greater than average salary, but we're not allowed to because aggregate operations can't appear in a where operation. So scalar subqueries get us around this problem. So what we're doing is saying select average salary from staff. Well, that is a valid select because the average is now only in the select clause. That will evaluate to a number, a salary, which will get substituted in there. Let's say it's 17,000. Then 17,000 this will get replaced with 17,000. Same thing up here, where you say minus select average from staff, it is going to end up as being replaced with 17,000. Okay, and again, don't worry about repeating it twice. A good query optimizer should only do that query once. Of course, a crappy one will do it twice, but you get what you pay for sometimes. Yes?
So for that second one, could you say saldiff instead of subquery since you said as?
Good question. I don't know, and I don't have this set of relations in my database. So the question was, could I use saldiff the second time? I tend to think not, because I think I would have done it, but I will try that afterwards and see whether you could use saldiff or not, because it certainly would make it more easily understandable. Okay, so that's how the query resolves. The two subqueries get evaluated first. They both evaluate to 17,000. So we're now selecting all staff whose salary is greater than 17,000 and subtracting 17,000 from the salary, which gives us the amount by which their salary exceeds 17,000. Okay, so we'll get into subqueries more fully on Thursday. We'll also get into SQL's data definition language on Thursday. So the data definition language will allow us to deal with the structure of a relation. Thus far, we've only been working within an established structure and retrieving values or modifying values. So on Thursday, we'll talk about how we deal with structure.
I actually just answered my own question because you said you named the difference as saldiff.